So with all the dependencies installed, we're now ready to code. But before jumping into the code, I wanted to lay out the plan here. Our focus is on first testing the prediction logic, which will call the LLM on OpenAI using the API key. This would first be done locally, and then we will gradually build on it to ultimately deploy in ECS and scale. So to get started, we would first need the OpenAI API key. So go to OpenAI and get a new key if you already haven't, and save it on your system. Or you can refer to the README of this chapter for detailed steps on getting your API key from OpenAI. To systematically build the application, we would first develop our app.py script. In the app.py script, we will first write the core part of the code, which uses the API key, and LangChain to call the LLM and generate a summary of the user provided text. So without further ado, let's dive in. So basically, we now have our VS Code. VS Code should have a folder which represents your project folder, and inside that folder there should be just one file, which is the requirements.txt. So all these packages are installed. As you can see, like my terminal of VS Code shows the base like conda environment which we have. So we will basically be switching to the new environment which we created in the last video. So I'm just going to present shift command and P, and shift command and P, and we have Python interpreter. We go to LLM applications. So with that, we'll open new terminal, and the new environment has been activated now. So we'll just clear this out. Okay. So with that, we create a new file called app.py. And inside app.py, we'll start importing the packages which we need for this application. The first one would be OpenAI. Then we would need import OS. We also need LangChain, LangChain.text splitter. And from this, we would need the character text splitter. From LangChain, we will be using chains. And from chains, since we need to summarize this, we will summarize the user input. We will be using the summary chain. That way to do that would be load summarize chain. Lastly, from LangChain, we would also need LangChain.docstore, and from document, we would be importing our document. This would be, I'll explain what each of these lines means after we import the packages and as we come to the code. So then from LangChain, we import. Sorry, I'm really bad at spellings. OpenAI. OpenAI. Okay, all right, cool. So we also would be needing JSON in later part of the code. So let's just import them now. And we also would need base 64. And as we build on this, we would import packages corresponding to AWS, but more on that later. So the first thing would be we define our API key, which would be sk something something. You can just paste your API key here. I won't paste that here for obvious reasons, but in the next video where I will show you how the application works, I'll show you a complete demo. So just go ahead and paste your API key. Please note that unlike other tutorials or articles which you see online, most people either like place their API key directly in the code itself or save it in the environment variable or maybe like create an .env file. However, when building software, especially using Docker and containerizing your application, these methods are really not the recommended approach. And I will talk about that as we build on this application, like how exactly can you inject your API key into your application, but more on that later. So now let's write our prediction logic, which is basically prediction pipeline, which receives a text from the user, and then let's just print this out like we are exactly inside prediction pipeline. The reason why I'm writing this is because when LangChain executes, we need to see which particular part of the code we are currently executing, and we can then get rid of this as we deploy it on ECS later. So next part would be we use the character text splitter from langchain.textSplitter to split our document, and separator would be a line space /n, and then chunk size would be let's say 1000, and then chunk overlap would be let's say 20. So what that means is, let me expand this window. What that means is like as we read through the documents, we will take 1000 tokens of like words. Like we will take 1000 tokens, the first 1000 tokens, then split them, and the next 1000 tokens, so on and so forth. And between each chunk of text which we have broken down, there would be an overlap of 20 tokens overall. So next we can take, we use this text splitter to create text chunks. And the way we do that is using text splitter dot split our text, and inside we pass in the actual text which the user would be passing in. For example, I have taken a pretty big chunk of text. I'll show that later. But for now, let's just follow along with the tutorial. So then we want to print the text chunks size. And the reason we do that is because GPT models 3.5 or 4 are supposed to handle only a certain number of tokens at a time. So we want to know that we're not exceeding the model's capacity to handle chunks. That is why we print it. I usually do it at work, and then we maintain a track of like, do we want to pass in all the text at once, or do we want to pass in a windowing fashion? So that would be extra code. Luckily for us, like LangChain does it for us. So but when I was working with like directly with GPT models without using LangChain, I had to write my own functions to pass in the text. Okay, so next we initialize our LLM, which would be done using OpenAI, and inside this we have to pass our API key. So, and this would be initialized to this particular key which we have declared as a global variable. So LLM is equal to OpenAI, and OpenAI is this particular thing, and then OpenAI API key is equal to API key. Then we basically pass in. We take our text document. We take our text chunks which we have created. We iterate through each of these chunks, and we'll create a document object. So let me first write down the code, and then I'll explain what I mean by that. So let's say for T in text chunks, like all the chunks which we have created of that text, we iterate through each of these chunks, and then from each of these chunks, we basically parse out the content on that specific chunk. So page content is equal to T, where T is iterates through all the chunks which we have created. So for example, you have 10 chunks of text. It iterates through the first chunk. All the text is extracted and is passed into the document object class type, and a document object has been created for that respective chunk. And all of these chunks are then passed into respective documents, and we ultimately get a document object type for each of those chunks, which are then stored inside a list. That is why you have a list like outside it. Once that is done, we basically build a LLM chain. So let's use the load summarize chain. Inside this, we pass in the large language model, which we have just initialized here. And then we say chain type equal to, let's say, map reduce. I'll explain what this means in a second. And verbose is equal to true, because we want to see like the inner workings of the chain when we actually generate a summary of the user input. And what map reduce does is basically, let's say you have a large corpus, an entire book. It divides that books into different chunks. Let's say there are 500 pages in that book. So there would be, each page contains 1000 words. So let's just try to imagine you have 500 pages. Those 500 pages are placed one after the other. Page number 1000 words, page number 2, again 1000 words, so on and so forth. We first summarize the first page, then we summarize the second page, so on and so forth, all the way to the 500th page. And then the summary of each of those individual pages is then re-summarized to basically generate an overall summary of the entire book. And the way that is done is using a map reduce fashion, like just like in distributed systems. So once that is done, we build our summary, which would be chain. We take this chain, the chain which we have created, and we do a chain.run. And inside this, we pass in the different documents which we have passed out from each of those text chunks. And once that is done, we return this summary, and the respective text would be predicted. Now in the next video, what basically I would be doing is I'll define my text here, some kind of a text. It could be pretty long text, and I'll be calling the prediction pipeline along with this text to show you how like this particular chain works. I'll be initializing my API key, but like I'll be hiding it for obvious reasons. I'll just show you how the code actually works. So see you in the next class then.